The two functions that I'm gonna use in explaining what convolution is like this. Both are actually localized function, and when I vary the parameter t, and the translation of the g will be seen. Let's see. And the dotted line is the resulting function of the convolution. Here, the integration of the folded function versus t parameter. And I will explain the convolution, what the convolution is, step by step. Let's begin. Convolution is defined to be a function h of t, and is also defined to be the definite integral of x from minus infinity to infinity of two functions multiplied fx and g t minus x, but the function g is reflected to the y-axis and translated according to t, and it has a sort of symmetry-like property, which means when we exchange the function f and g, the result remains the same. I'm using the two functions as was seen from the GeoGebra scene, and I will return to the GeoGebra and explain step by step. Here are only two functions that I'm using, the original form of the function, and when I vary, the function gx will be moved to the right, like this. And here we can find out what the multiplied function look like, and the integration of the multiplied function is the shaded area, and will continue to vary and plot the value of the integration versus t, and it is the trace of the point A. So I'll begin the whole process. As it is seen, what matters most is the folded area of the two functions and the integrated value. I hope it will help you understand what convolution looks like, and I'll continue to post new explanation of the discrete convolution and two-dimensional convolution and such if you support this by subscribing.